Okay, this is the last unit that we're going to do before the semester ends, and actually it's just a little snippet of the unit. We're going to do the majority of this unit after Christmas break. So before we leave for the Christmas break, I want us to make sure that we know how to write equations and balance them. Okay, so this is where all of those learning how to write formulas is going to come in handy. The better you know that, the easier this unit's going to be for us. Okay, so let's start with what the equation is going to look like. So we have to have the correct formula, and of course the reactants come before the arrow, and that's because they react, so they come before the arrow, and then the products are going to come after the arrow. It's because they're being produced. Okay, we will be utilizing, of course, the law of conservation of mass is why we balance equations, because remember, mass and energy, both of those laws must be satisfied. And for us, mass and energy cannot be created or destroyed in ordinary chemical reactions. Therefore, the same number of atoms must appear on each side of the chemical equation. So if I start with 4 carbon, after my reaction is complete, I need to end with 4 carbon. They're not necessarily still together as 4 carbon. They may be in different arrangements, but there has to start with 4 and end with 4. Same thing with mass. If I start with 15 grams of reactant, I need to end with 15 grams of product. Okay. When we're writing a chemical equation, the states of matter should be indicated for each product and reactant, and we'll look at that in just a second. When we're writing these, we really want to remember our Brinkelhoffs. This is going to be where it's very, very important. So when you see things like produces hydrogen or hydrogen gas, we would write that as H2. Or if it says oxygen was released, then we would be writing that product as O2 and not just oxygen. If you don't write them as the Brinkelhoffs, it'll be next to impossible to balance, and you obviously will get it wrong. Okay? So remember that when we have chemical changes, it's always going to have either a release of energy, which would be exothermic, or sometimes we have to add energy to the system to get the reaction to happen, and then that is endothermic. So let's talk about some of the symbols that we are going to need to be able to do this. Oops, discard, don't want to do that. So here we go, some of the symbols. So first of all, the way that we separate 2 or more reactants is going to be a plus sign. So we would say carbon plus oxygen yields carbon dioxide. And the way that we show yields is our arrow. It does not mean equal to, it means yields. Okay? If it is a reversible reaction, which many are, we show that with a double arrow, meaning it can go forward and it can go backwards. If we're designating a reactant or a product in the solid state, we're going to put a little parentheses S behind it, okay, meaning it's a solid state. One of the alternatives to S is an arrow down, showing that a solid product was produced. Okay, we can only do this for products, not for reactants, and that's basically just showing that a precipitate was formed. We don't use it that often. Mostly we just use the S, but I just wanted to show it to you in case you see it. For liquids, we indicate with an L, and I do a cursive L. I try to do a cursive L. Apparently I don't do a very good one, but I try to do a cursive L to show that, because if I was to put just a lowercase l, you might think it's a 1. Okay. For aqueous, and y'all have seen this a couple of times, especially when we're talking about acids, aqueous is AQ, and we put that in parentheses. I bet you could guess by now that a gas is a G. An alternative to gas, only again for product, is an arrow going up, showing that the gas released. Okay. I need to move this up, so give me a second. Discard. And then the last 2 here are going to be if we had supplied heat to the reaction, we're going to show that by drawing the arrow for yields, and we're going to draw a little triangle above it, and that's showing that we heated the reaction. Sometimes it might say plus heat, and then if we're going to show a catalyst, and then we would show that, and then sometimes we might put platinum as the catalyst, or sometimes That might be a chemical like manganese oxide, and so that's where a catalyst. And a catalyst is something that speeds up a reaction. It's not used in the reaction. It doesn't react. It just speeds up the reaction. Okay? So those are the things you will see in a chemical equation. So now let's look at how we're going to make sure we do an atom inventory count. Sorry about this. I could not find my PowerPoint, and so we're just going to do it the old-fashioned way. Okay? So whenever we're doing our atom count, remember when we write our formulas, we have subscripts, okay? And those are the small numbers that are within the formula, and they only count for what comes right before it, or if it's in parentheses, what goes completely in it. So that's how we count the subscripts. But if you have a coefficient, which is the large number, which is the way we're going to balance the equation, that coefficient counts for everything that comes behind it. And so let's look at this example real quick. In this case, I have 3 sodium sulfates. So the total number of atoms of sodium would be 3 times 2, so it would be 6. So the total number of sulfur would be 3 times just 1, so it would be 3. And then, excuse me, the total number of oxygen would be 3 times 4, so 12 of oxygen. Okay? So now for the next one, we have calcium phosphate. So for the number of, that should say calcium. Sorry, that's a typo. So the number of calcium would be 4 times 3 is 12. For phosphorus, I would do the 2 outside the parentheses times 1 is 2. So then 2 times 4 would be 8 phosphorus. And then for oxygen, I'd have to multiply what's outside the parentheses first. So 4 times 2 is 8. And then 8 times 4 would be 32 oxygen. So that is how you do the atom count of that. Okay? So now let's talk about how we actually write and balance the equation. So first thing is we write the equations using the correct formulas. Okay? And then once we know we have the correct formula, we do not change them again. That's very important. This is where I usually make the classes take an oath saying, I do solemnly swear that I will not change the subscripts, okay? Because you cannot balance it based on changing the subscripts. You have to balance it with coefficients, okay? So then after we have the formulas written correctly, now we are going to balance the equation. And we're going to do this, remember, by taking an inventory on both sides of the equations and then using equations to balance those out, okay? And I'm going to stress we do not change the subscripts. All right, so here we go. We're going to practice this. Before we do, I'm going to give you a couple of hints, okay? And we're going to write these over here. My first hint is if it's got a metal, we're going to balance our metals first. Metals first, if they're present, okay? Second thing is treat polyatomics as one unit. In other words, don't count them up separately like, okay, there's 3 phosphorus and 3 phosphorus. If you balance the entire polyatomic, it will take care of itself. Now, if the polyatomic happens to break up, that's a different story, okay? And then if you're having trouble balancing, you're going to want to go back and double check that you wrote your formulas correctly. Because sometimes if it will not balance no matter what you've tried, you probably wrote one of the formulas. The first thing to check is make sure you wrote your Brinkelhoffs as diatomic. So that's the first thing you always want to check. And only change those subscripts if you realize, oh, I didn't write that correctly. Okay? So here we go. We are looking at A, when I have H2O yielding hydrogen and oxygen. So I look and see, my initial is that, yeah, they've got 2 hydrogens here and 2 hydrogens here, so those are balanced. But what's not balanced is oxygen, because I have 2 here and I have 1 right here. So the only way I can fix that is to put a 2 in front. So now my oxygen's balanced, but now my hydrogen's not. So hydrogen would be a total of 4 on the reactant side, and I only have 2 on the product side, so I'm going to add another 2 here. And then I do a double check. 4 hydrogen on both sides, so that's balanced, and 2 oxygen on both sides, so now that's balanced. Okay? So then I'm going to do the next one, and I see lead nitrate plus sodium is going to yield sodium nitrate plus lead. So we're going to do our metals first, and I see that I have one lead on each side, so it's good. And then I'm going to do my nitrates, which are polyatomics, and remember what I said, treat them as one unit. So I have 2 right here, so I'm going to add a 2 in front here. Remember, the only way you can balance equations is to put coefficients in front. You cannot change the subscripts. You can't say, oh, I need 2, so you throw a 2 behind something. You got to put it in front. So when I did that, I balanced my nitrates, but that made my sodium not be balanced, and so I'm going to just need to put a 2 right here, and now it's balanced. Okay? So now let's look at this next one, which is a combustion. Okay? And I'm going to give you a little hint on combustions. Okay? So, do you see I have CO2 right here and H2O right here? Okay? And then I have this oxygen right here. This oxygen right here has a 2 behind it. So no matter what I put in front of there, no matter what coefficient I put in front, it's going to end up being an even number because anything times 2 is an even number. Same thing with the oxygen that's in CO2 right here. So where the issue or the problem lies is with the oxygen right here in water. Okay, it's 1. So it's going to be odd if I put an odd number in front of it. So I always say the best thing to do is check, first of all, if you're going to have to put an odd number in front of water, it's not going to work because I can never make this oxygen right here be odd because no matter what I put in front of it, it's going to be even. Okay? Now this is only going to work for these combustion problems. It's not going to work for other things. Okay? So what I look at is I look at the hydrogen right here, and I see that if I divide that by 2 to see what I need to put here, I'd have to put a 5. That's not going to work. So I'm going to automatically just bump this up to 2. Okay? So now I would put 10 here to get 20 hydrogen. I have 2 times 4, so I need to put an 8 right here. And then if I count up my total oxygen, I have 8 times 2 is 16 plus this 10 right here. So I would have a total of 26 oxygen. And so I would need to put a 13 right here. Okay? So don't be afraid of the big numbers in front of oxygen. Okay? So that would be balanced now. Okay? So I'm going to erase this now that you have it so I can have room down below. Okay? So now that's how you just balance equation if you're just already have your formulas and whatnot. Okay? So now for writing it, which is going to quite frankly be the harder part for you guys because you sometimes still don't know your formulas, although it seems like most of you did a lot better on the last test on knowing your formulas. So in this one we're going to say iron, and when it's just iron by itself, it does not have a charge. We're talking iron metal here. So we're going to say Fe plus sulfur all by itself does not have a charge. It only has a charge when it's in a compound. Okay, so now we're going to say Fe plus sulfur yields, and then it tells us our formula, iron 2 sulfide. Now they have charges because they're in a compound. Iron 2, of course, is saying it's a +2. Sulfide, based on being in group 16, is a -2. So we would write that as FeS. Okay, then we double check, is it balanced? And this happens to be balanced as is, so it's balanced. So we're done with that one. Now we look at the next one, zinc. Zinc by itself is just zinc. No charge. It's not in anything. Okay? Plus copper 2 sulfate, so that means we have a +2 and a -2. So that's going to be CuSO4. So then it makes zinc sulfate. So now we have a +2, still is -2. So we're going to do ZnSO4. And then plus copper. When copper's all by itself, it's just copper. Okay? And that is probably one of the big mistakes that kids make in the beginning is when they see zinc by itself, they go look at their pink sheet and they go, oh, zinc's a +2. It's not a +2 when it's by itself. Okay? It's only a +2 if it's bound with something. And then same thing with copper. Here it's got a charge in this one because it's bound, but over here it's just by itself. And that one is already balanced. Okay. Now let's do silver nitrate. Plus sodium bromide yields silver bromide plus sodium nitrate. Okay, so when we're in this unit right now, for this first part, don't worry about putting the solids, liquids, and gases in aqueous, because we have to learn the types of reactions before you'll know what these things are. For instance, this would actually be a solid, but you won't know that until we do precipitation reactions. Okay, so let's do a couple of more examples for you guys. Oop, there we go. Let's do this last one. Ferric chloride. That's the old style, and I would not hold you responsible for that. So basically what it is iron 3. So it's going to be FeCl3 plus ammonium hydroxide, so NH4OH, yields iron 3 hydroxide plus ammonium chloride. So now we're going to balance that. So my iron is balanced, so we're good there. Okay. So I'll see my hydroxide, and remember polyatomics we're going to treat as one unit. So that since I have 3 right here, I'm going to put a 3 right there. Okay. But then what did that do to my ammonium? Because remember, ammonium is a polyatomic as well. So it gave me 3. I only have 1 over here, so I'm going to put a 3. And look what that did for chlorine. It went ahead and balanced chlorine when I did that. Okay? So the best thing to do is just practice this. You're going to have 2 practice worksheets on it. The more you practice it, the easier it becomes. You have a few in your notes as an extra practice sheet that you are welcome to do. I'm going to do a couple of them now just to do a couple more examples with you. So let me get a new screen here. And so let's do this, and let's see, let's do number 1, okay, on your practice worksheet, and it says sulfur plus oxygen yields sulfur dioxide. So sulfur is just S because it's by itself. It doesn't have a charge by itself. And then oxygen. Oxygen is one of our diatomics, so we're going to write it as O2. And then it says it yields sulfur dioxide, so it's going to be SO2. And then that one is already balanced as is, so it's good to go. Okay? Now let's do number 4. I'm just going to skip around a little bit. Okay? Number 4 says hydrogen plus chlorine yields hydrogen chloride. Okay? And so that's going to be a gas since it says hydrogen chloride. If it was aqueous, it would say hydrochloric acid. So hydrogen is a Brinkelhoff, so it's going to be written as H2 plus chlorine, also a Brinkelhoff, so Cl2, and that's going to yield hydrogen chloride. So now when I see that, I've got 2 and 2, so it's very easy to fix by putting a 2 in front of hydrogen chloride. Okay. So now let's do number 10, which says aluminum sulfate. So aluminum sulfate is going to be Al2SO4 plus, and try to leave yourself room for putting your coefficients, plus calcium hydroxide, which is CaOH2, yields aluminum hydroxide plus calcium sulfate. Okay, so right now my metal of calcium is balanced, but my metal of aluminum is not. So the only way I can take care of that is by putting a 2 right here. Okay, so that's taken care of. But now I'm looking at this right here, and I see that I have 3 sulfates. And remember, if I treat sulfates as a polyatomic, same on both sides, that means I'm just going to put a 3 right here. And then what did that do to calcium? It made calcium out of whack. So now I'm going to put a 3 in front of calcium, and then look what that did for my hydroxides. 3 times 2 is 6. 2 times 3 is 6. So we're going to double check that I have 2 aluminum on both sides, 2 aluminum. So check, check. I have 3 sulfates, and I have 3 sulfates, so the sulfates are done. I have 3 calcium and 3 calcium, so they're done. And I have 6 hydroxides, and over here I have 6 hydroxides, so everything is balanced. All right, so let's do one last one, and then I think that's enough practice, and you can get going for your worksheet, and that's just number 12. So I have aluminum oxide, Al2O3, yields aluminum. Aluminum all by itself, it's just aluminum, plus oxygen. And oxygen is a Brinkelhoff, so O2. So I see that I have a... I'm not going to do the aluminum first on this one because I see something right off the bat. Now remember, those were hints that I gave you. If you see something glaringly obvious to you to balance, then get that done, and the rest will take care of itself. So what I see right off the bat is I have 2 oxygen and 3 oxygen. The only way that I'm going to get those to balance out is do a multiple of 3 and 2. So I'm going to put a 3 right here, and that gives me 6 oxygen, and I'm going to put a 2 right here, which gives me 6 oxygen. But now it gives me 4 aluminum. So I'm going to put a 4 right here, and now it's balanced. Okay? So you have your worksheet. Work on that. It is going to be due in class tomorrow because you're going to get a new one because we're going to practice this a lot. We are going to be taking a quiz over this on Monday. So we're going to do quite a bit of practice in these next 2 days, and then we're going to take a quiz, and then we are done with material for the semester. And then we're hopefully going to do our t-shirt project if they come in time. Okay? See you tomorrow.